Argon is an inert gas used in arc welding and cutting. Argon protects the weld area from oxygen and water vapor because it is unreactive. Argon is one of several noble gases, all of which are unreactive. Noble gases are unreactive because they have stable electron configurations, unlike other elements. The noble gas argon has 8 electrons in its outer shell. This full outer shell means that the argon atom is stable and unreactive, as with other noble gases. This number of electrons in a stable outer shell leads to the octet rule. The octet rule is a chemical rule of thumb, so it doesn't always apply. But in general, the octet rule means the atoms of main group elements tend to combine so that each atom has 8 electrons in its outer shell. This number of electrons giving the atoms in a molecule the same configuration as a noble gas. Most elements have unstable electron configurations. These elements will react to lose or gain electrons so that they have the same electron configuration as the nearest noble gas. How do we know which elements follow the octet rule? The periodic table is arranged into rows called periods. The columns are called groups. The groups indicate an element's key characteristics and whether it will follow the octet rule. Elements in groups 1 and 2 and 13 through 18 follow the octet rule in that they try to get 8 electrons in their outer shell. Elements in group 1 have 1 electron in their outer shell, like lithium. Elements in group 2 have 2, like magnesium. Elements in group 13 have 3, like aluminum. Elements in group 14 have 4 electrons in their outer shell, and so on. Sodium and chlorine, which are in the same period as the noble gas argon, both follow the octet rule. That is, both elements react so they have 8 electrons in their outer shell. This is why sodium and chlorine, even though they are highly reactive, react to form a stable ionic compound. Sodium donates its electron to chlorine. The reaction creates a stable molecule of sodium chloride or table salt. When this happens, the atoms of sodium and chlorine ionize. They form ions. An ion is an atom or molecule with a net charge because it has lost or gained 1 or more electrons. The atom becomes charged because the number of electrons no longer equals the number of protons. Lewis dot diagrams are another visually useful way to understand the octet rule. Sodium has 1 electron in its outer shell, represented here by a dot. The 7 dots around chlorine represent its 7 valence electrons, with 1 spot to fill to have a full outer shell. When sodium and chlorine combine, the atoms become stable and also have a charge. However, not all elements follow the octet rule. Hydrogen, for example, is in the same period as helium. It therefore reaches stability with only 2 electrons in its outermost shell. This is what happens when hydrogen reacts with oxygen to form water. Although hydrogen does not follow the octet rule, oxygen does. Quite a number of other elements, especially those with higher atomic numbers, do not always follow the octet rule. However, elements and molecules we deal with in everyday life and in chemistry class usually follow the octet rule. You can think of chemistry as all the elements trying to achieve the same number of valence electrons as the noble gases. This tendency is reflected in the periodic table in chemistry.
How come some insects are able to walk on the surface of a pond, but you quickly sink to the bottom when you try to walk on water? And why do lakes freeze from the top down in winter? In a word, the answer to all of these questions is polarity. Water is a simple molecule made up of 1 oxygen atom and 2 hydrogen atoms, but it is essential to life. In fact, water makes up approximately 60% of the adult human being's body weight. The polarity within those water molecules gives this common substance the properties that make it unique and life-sustaining. Polarity refers to the unequal sharing of electrons within a molecule. For water, the bonding between the oxygen atom and two hydrogen atoms within a single water molecule is like a tug of war between a big, strong football player and a cute little toddler. Oxygen is a larger atom with more protons in its nucleus than hydrogen. These positive charges are like a person's physical strength. They are able to attract the negatively charged electrons in the bond, just like a strong individual is able to overpower a weaker individual in a tug of war. So, oxygen is able to attract more than its fair share of electrons. Because hydrogen is smaller and has less strength, or fewer protons, it loses the tug of war and attracts fewer than its fair share of electrons. So the oxygen in water behaves as though it's negative, and the hydrogens behave as though they're positive. The bonds within a single water molecule are called polar covalent bonds. Covalent means that the electrons are shared. But, as we just learned, polar means that these electrons are not shared equally. In water, the oxygen acts negative, and the hydrogens act positive. Since negative and positive attract, that oxygen is attracted to the hydrogen atoms in neighboring water molecules. A special type of bond forms between water molecules known as a hydrogen bond. Hydrogen bonds don't just happen in water either. They can form between a water molecule and different substances that are polar or ionic. Water's ability to stick to itself is called cohesion, while water's ability to stick to other substances is called adhesion. Now, think back to the initial questions. First, why are some insects able to walk on water? Surface tension due to hydrogen bonding creates a thin film on the surface of water that gives enough resistance for super light insects to walk on. You can't walk on it because the hydrogen bonds aren't strong enough to hold you up. Why does ice float on top of liquid water? For most other substances, the solid state is more dense than the liquid state. But that is not the case for water. Hydrogen bonds keep water molecules farther apart in frozen water than in liquid water. The farther apart the molecules are, the less dense that solid is. So ice is about 9% less dense than water, which means it floats on the top. That's why lakes freeze from the top down and aquatic life is able to survive through a cold winter every year. It is the polarity of the water molecule and the resulting hydrogen bonding that account for water's unique properties. So, the reason that water is so special, from inside your cells to the world's oceans, is simply because it is a polar molecule.